Okay, so you've seen the videos, right? Those robot dogs doing backflips and all that crazy stuff. It's awesome. But have you ever stopped and asked yourself, why legs? I mean, why go to all that trouble? Well, today we're going to pull back the curtain on those viral clips. We're diving deep into the science of these walking machines to figure out why they are such a massive, massive leap forward for all of robotics.
So let's kick things off with a question that honestly gets right to the point. Think about it. Why can't most robots, the ones you see in factories, the ones zipping around warehouses, why can't they handle something as simple as a flight of stairs? It sounds so basic, right? But that one little problem, it actually uncovers a massive challenge for robotics.
And that right there, that's what engineers call the mobility problem. It's pretty much the core reason why it's so ridiculously hard to build robots that can just get around in our world.
Okay, look, wheels are amazing. On a nice, flat surface, they're kings. Think about a factory floor or a highway. They're super fast, super efficient. But the second you throw a wrench in the works, like a single staircase, a pile of rubble from a disaster, or even just a bumpy hiking trail, they're toast, completely useless. The simple truth is, most of our world just wasn't designed for wheels.
So, if wheels are out for the tricky stuff, where do you even begin to look for a solution? Well, engineers turn to the undisputed champions of getting around on this planet, us, and, every other animal that walks, runs, or climbs.
Yep, you guessed it. Legs. It's kind of funny. Instead of literally reinventing the wheel, engineers decided to copy something way, way older. They're trying to mimic the incredible adaptability that evolution has been perfecting for billions of years. The whole idea behind a legged robot is to let it move through the world, well, just like an animal does.
So what's the secret sauce that makes a robot leg work? It all boils down to one key concept: articulated joints. I mean, think about your own leg for a second. You've got a hip, a knee, an ankle, all joints connecting different parts. A robot's leg is the exact same idea. It's just segments connected by these joints. The only difference is that instead of muscles, they have motors and actuators doing the work, letting the leg bend and move with incredible precision.
And this table breaks down the different flavors of legged robots really well. You've got your bipeds, right? 2 legs, just like us. They're super agile, but man, they have to work constantly just to stay balanced. Then you have quadrupeds, 4 legs. Think of a dog or a horse. These guys are way more stable because they can always keep 3 feet planted on the ground while moving the 4th. And then for the ultimate instability, you have the hexapods, 6 legs. They're usually based on insects, and they are so steady on their feet they can pretty much walk over anything.
Okay, so giving a robot legs is one thing. That's just the hardware. The real magic, and honestly the biggest headache for engineers, is teaching the thing how to stay standing. And that brings us to the incredible art of balance.
I love this phrase because it's so true. Think about a car or a wheeled robot. It's just stable. You park it, and it stays there. But a legged robot, especially one with 2 legs, it's basically in a constant state of controlled falling. Every single step it takes is a fall that it catches just in time. It's this nonstop active dance that takes a ridiculous amount of brain power, or, computer power.
So how does it pull off this incredible balancing act? Well, it needs senses, just like we do. It has gyroscopes, which are basically its inner ear, constantly telling it if it's tipping over. It's got accelerometers, which let it feel acceleration and motion, kind of like how you feel pushed back in your seat when a car speeds up. And then in its feet, it has force sensors. These are like the nerves in your own feet, telling the robot exactly how hard it's pressing on the ground and what the surface is like. And all of this data, it's being crunched in real time.
And here's how that all gets put together. It's called the balance algorithm, and it's basically a super fast, never-ending loop. Step 1, sense. The robot uses all those sensors to figure out its exact position in space. Step 2, calculate. Its brain processes all that data to figure out where its center of gravity is and where it should be. And finally, step 3, act. It sends commands to its motors to make these tiny little micro-adjustments to its joints to stay perfectly balanced. And this whole loop, it happens hundreds of times a second, way faster than you can even blink.
But look, just staying balanced while standing still is only half the battle, right? You have to actually move. And that's where something called gait planning comes into play. Just think about it for a second. You walk totally differently on a smooth sidewalk than you do when you're trying to cross an icy parking lot, right? You take different kinds of steps. A robot has to make those same kinds of choices, constantly planning the perfect sequence of leg movements for whatever ground it's covering.
All right, so we've spent a lot of time on the how, the tech, the balance, the movement. Now let's talk about the why. Why are people pouring so much time and money into this? Because all of this mind-blowing technology is being built for some really, really important jobs. These are literally robots on a mission.
And you know, one of the most powerful examples is in search and rescue. Imagine an earthquake or a building that's collapsed. These machines can go into places that are just way too dangerous for people or even rescue dogs. They can climb over piles of rubble, navigate through unstable structures, and go up broken staircases to find survivors. They can be a lifeline where no other machine and no human can go.
Then there's the military and exploration side. You've got these four-legged robots acting as robotic mules, basically, carrying hundreds of pounds of gear for soldiers over terrain that no vehicle could handle. And then, think bigger. Think off-world. This is exactly the kind of tech we'll need to explore the caves, canyons, and crazy landscapes of Mars, or the Moon, or anywhere else we decide to go.
And of course, there's the big one, humanoid assistance. I mean, if you want a robot that can actually be useful in our world, in our homes, our offices, our hospitals, it has to be able to navigate a world that was built by and for things with legs. We're talking about robots that could help with elder care, work in a lab, or just naturally move through a building, opening doors and climbing stairs just like a person would.
So where do we go from here? The progress has been absolutely insane, but let's be real, there are still some huge challenges to overcome. And that brings us to our last section. What's the next step for these walking machines?
Right now, it all comes down to this big trade-off. The huge strength, the pro, is their insane versatility. They can go basically anywhere. But the flip side, the con, is that they are so complex. All that balancing, all those moving parts, it eats up a ton of battery power. And with so much complexity, things can and do break.
But don't worry, the smartest people in the field are all over this. They're tackling it from every angle. We're seeing new lightweight materials that are stronger than steel. They're designing way more efficient actuators, those robot muscles we talked about. The software is getting smarter too, learning how to save energy with every step. And some are even experimenting with these wild hybrid designs that have both legs and wheels, trying to get the best of both worlds.
And that kind of leaves us with a really big thought to chew on. For decades, right? We've been designing our world to be simple and flat for our robots. But now we're finally building robots that can handle the world as it actually is. Messy, complicated, and full of obstacles. So really the question isn't if these machines will walk among us. That seems inevitable. The real question is, how will our world change when they do? Thanks for diving into this with me.